Welcome to Waidsum Academy. Today we'll be looking at fraction and recurring decimal. Fraction and recurring decimal. So if you're given, for example, 1 all over 5, you'll be asked to change it to decimal sometimes. Be asked to change it to decimal, okay? If you want to find the recurring decimal, we have to change this to decimal. In doing that, sometimes we have to do the long division. Sometimes we have to do the long division. For example, if I want to do a long division for this, I have this. I put my 5 here outside because I'm dividing 1 with 5. We are dividing 1 with 5. So what we do, say how many times can 1 divided by 5 is 0 times. 1 divided by 5 is 0 times. So this is 0 times. Then we write 0 there and then we progress. 1 divided by 5 is 0, so we put a decimal point, and then we include a 0 here. Once we put a decimal point here, we have to include a 0 here. So now you say 10 divided by 5, which is 2. 10 divided by 5, this is 2, you write the answer here. So you say 2 multiplied by 5, you get 10. So when you subtract these two, this number and this number, you get 0, 0, which means that's the end of the division. So it means if you put in decimal form, this fraction 1 all over 5, you're supposed to get 0.2. You're supposed to get 0.2. Is that okay? So which means if we put in decimal point, we're supposed to get 0.2. Okay, so that's that for converting a fraction to a decimal. Converting a fraction to decimal. So many different fractions. We have equivalent decimal of a given fraction. Fraction is a part of a whole. Okay, fraction is a part of a whole. So we'll be given some of this fractional distance. We have to find the terminating decimal. For example, 1 all over 5 is equivalent to a terminating decimal because we just did for 1 all over 5. And in 1 all over 5, we got 0.2, which is a terminating decimal. A terminating decimal is a decimal which ends. You know, we have decimal that does not end. You keep going and repeatedly keep going. So that's a non-terminating decimal. Okay. We also have a recurring decimal, a decimal that keep repeating like 0.33333333. We have a recurring decimal, but we have a terminating decimal. So most of the fraction you can produce a terminating decimal. Like 1 all over 3 is a recurring decimal. A recurring decimal because if you do that, if you do 1 all over 3, if you bring it here, you're going to get a recurring decimal. For example, like 1 all over 3. If we do a long division for 1 all over 3, let's say we have 1 here and we have 3 outside, we're going to have a recurring decimal. A recurring decimal. So, for example, 1 divided by 3, we're going to get 1 divided by 3, we will get 0 because 1 cannot be divided by 3. So, we have 0, we put a point here, and then we add 0 here. So when we add 0 here, we say 10 divided by 3, we get 3. 10 divided by 3, we get 3 whole number. If you multiply, you get 9. So if you subtract, you get another 1. And when you have 1, you cannot divide with 3, so you add 0. Henceforth, you keep adding 0. So you say 10 divided by 3, you get another 3. So 3 times 3, you get 9. If you subtract, you get 1. And you add 0. You add 0, it becomes 10. 10 divided by 3, you get 3. You keep having the same thing. You keep, like you swing it back and forth. You having 0.33333 continuously. So it's a recurring decimal. We call this 0.3333. To continue, even you do 1 million times, you keep getting 0.333333 like that, in that manner. So this is called a recurring decimal. This is called a recurring. Why this is called a terminating decimal? A terminating decimal is a decimal that ends. Terminating. So I just write terminating decimal here. Terminating is a decimal that ends. Why a recurring decimal is a decimal that keep repeating itself. Okay? A decimal that does not end, it keep repeating itself. Either same number repeating itself, or 2 different numbers repeating themselves, or 3 numbers repeating themselves. So this is a terminating decimal. Why this is a recurring decimal. This is a recurring decimal. This is a recurring decimal. So we say this is a recurring decimal. So when we relate fraction, we can relate it to either terminating decimal or a recurring decimal. So fractions are easily converted with long division method, are easily converted to decimal, okay? Or they can be converted to percentage by multiplying with 100. If you want to convert this fraction to percentage, all you need to do is to multiply this fraction with 100. So when you multiply with 100, it becomes a percentage, okay? When you divide them, you get a decimal. When you multiply with 100, you get percentage. Okay, so this is that for that. Now let's take a look at what we have, still on what we have. Okay. So this is what we get when we give you this type of fraction. If you have 2 over 3, you also get a terminating decimal because this can terminate 2 over 3. So if you do the long division, let's practicalize that. Let's take a look at that. If you do the long division, for instance, question number 3, let's say this question number 1, this question number 2, this question number 2, and let's say this question number 3. So if you give it 2 over 3, if you're given 2 over 3, and they ask us to convert this to either a terminating decimal or whatever decimal. We also be given terminating decimal. They ask us to convert it to fraction. So vice versa, you should be able to. Last time I treated a problem on how to convert a terminating decimal to a fraction. How to convert it to a fraction. We can actually take one of these. So if you want to do this, we have, like we did in this one. So we put the 3. The denominator is always outside. Have you noticed that? The denominator in the division is always outside, while the numerator is inside this division symbol. Okay? So that's the first thing we need to bear in mind. The second thing we need to bear in mind is to say this inside divided by the outside. The inside divided by the outside. 2 divided by 6. 2 is smaller than 3, we say 0. 2 is smaller than 3, we put 0, then we put the decimal. After that, we put a decimal, then we add 0 to this one. Okay? Now what we have is 20 divided by 3. 20 divided by 3, we have what? 6. We have 6. Because 3 times 6 is 18. 3 times 6 is 18. So you get 18, right? 3 times 6 is 18. So you subtract. The next step is to subtract. Okay? We revise the division, long division somehow. You subtract, you get 2. So 2 cannot be divided by 3. You have to add 0. So we're going to be having something that is repeated itself. So you again say 20 divided by this, you get 6. 6 times 3, you get 18. So same thing will be repeated or reoccurring. Okay? So this is a recurring decimal. You subtract, you get 2. You add 0, you get 20. You again say 20 divided by 3, you get 6. 6 times 3, you get 18. You subtract again, you get 2, and you add 0. So we go to so you can just say this is a remainder 2. You can say 0.6 remainder 2. Okay? Because it keep remaining 2. Keep remaining 2. So our answer will be 0. Our answer for this division will be 0.6666. It will keep reoccurring. Keep reoccurring, okay? A decimal that does not terminate. It keeps going for us. So this is what we get when we try any of this that is given to us. Is that okay? So now let's take a look at these 3. So when you have this type of decimal, instead of writing 0.66666 because it's recurring, instead of writing 0.66, you can just write 0.6. You put a dot on top. Okay, the ones that are recurring, we put dot. So that's when you see dot. Anyone you see dot on top, it means it's a recurring decimal. Anyone you see the dot on top of them, it means it's a recurring decimal. So this one can simply be written like this. Instead of because the 6 does not stop after 3, 6. It keeps going, 6, 6, 6, 6. So the best way is just to write 0.6, and then we put a dot on top of 6. What this dot means is that this 6 keep repeating itself. It's a recurring decimal. It means this is a recurring decimal. So this one can simply be written as 0.3. Because it's a recurring decimal, we put a dot on top of 3. We put a dot on top of 3 because it's a recurring decimal. Okay, but the one that terminates, we don't need to put a dot on top of it. We don't need to put a dot up. So this we need to make a bring clarity of purpose. We need to bring a clarity of purpose to this. Is that okay? So that's that for this one. Let's see what we have next. Now here are some exercises. They're asking us to convert 1/4 to decimal. We have to convert to say 1/4 equal to 0.25, which is a terminating decimal. Yes. Why is it a terminating decimal? Because it's a decimal that ends. It's a decimal that ends. It's not a decimal that is reoccurring. It's not like reoccurring continuously or constantly reoccurring. So it's a terminating decimal. To show that, we can quickly show, and we see some of them. 1/5 is a terminating decimal. You see, 1/5 is a terminating decimal as well. 1/5. Okay. 4/5 is a terminating, obviously a terminating decimal. Okay. So all these we should be able to fill them in. Okay. Now, it's a work out the decimal equivalent of 1/9. Work out. So you have, is it a terminating or a recurring decimal? So you have to do the division. You have to do the division to be able to answer this. And then see, use your answers to part A and B to write the decimal equivalent of these fractions and write if each decimal is a terminating or a recurring decimal. If this decimal is a terminating or recurring decimal. So first of all, let's take one example. 1/9. Is it a terminating or recurring decimal? Okay. And then probably, first of all, is a work out the decimal equivalent. Decimal equivalent, first of all, you divide it, and then you know which other decimal has such equivalence. Now, let's take a look at this. For example, 1/9. Question number 4. Question number 4. Let's say if we have 1/9, we say 1/9. So to do this, we have to always do the long division. We have to use the long division method. Long division, we have to use the long division method. Okay, so we have to use the long division method. So we put this inside and this one outside. 9 is outside. The denominator is outside. Okay, the denominator is outside. Let's erase this one. Okay, let's move on. So we say 1 divided by 9 is not possible. We write 0. We put a point. It's not possible. So we choose another thing. So, and then we add 0 here. 10 divided by 9, 1. 1. 1 times 9, 9. We subtract, we get 1. We add 0 to it, become 10. 10 divided by 9, we get 1. 1 times 9, we get, so we'll be getting 0.11111. This is what we're going to get. Go, if we multiply, we get 9 again. And then we subtract, we get 1. So this is going to be repeating itself. And you add 0, you divide by, it's going to be repeating itself. So this is equal to 0.1111, which is equivalent to 0.1 dot. 0.11, this is the decimal equivalent of the fraction 1/9. And which is 0.1, and then we put dot on top. Now, if you don't convert to decimal, you will not know whether it's a recurring decimal or. Now you can see this is a recurring. Another question they asked was to tell whether this is recurring decimal or not, whether this was a recurring decimal or not. So we can tell this is a recurring decimal. It's not a terminating decimal. So this is recurring decimal. So you write recurring decimal. Okay, so every decimal you should do the long division to find out whether it's a recurring decimal or it's a decimal that terminates. If it's the one that terminates, then it's a terminating decimal. But if you keep repeating itself, or two numbers repeating themselves, or same number repeating itself, then it's a recurring decimal. Is that okay? So let's take a look at another example. For example, let's try 5/9. Okay, the rest you try yourself as student. Let's try 5/9. and see whether it's a terminated. Let's first of all find the decimal equivalent, and then we also find out whether it's a recurring decimal or a terminated decimal. So we say 5 over 9. 5 over 9. So if you want to find out, you must do the long division. So if you forgot your long division, this is a chance. We say the numerator has to be inside and the denominator has to be outside. The denominator, which is 9, has to be outside. So you say the numerator divide, the inside divide by the outside. The numerator divide by the denominator. The numerator divide by the denominator. So 0, right? Because 9 is bigger than 5, so we say 0. So here we say 0. 0 point. When you put the point, you have to add 0 here. You have to add 0 here. Now this becomes 50. 50 divided by 9. 50 divided by 9. Without a remainder. It's not 4, it's 5, right? 5. Because 9 times 5 is 45. So 5 times 9. So 5. So 5 times the 9, the 5 you write, multiply by the 9, you get 45. So you write 45 here. Write 45 here. After that, now you see you have to arithmetic, you have to subtract to find the difference. If we subtract, we get 5. 5 divided by 9, we will still get what? It's not possible, so we have to add 0 here. So it's still 50 divided by 9, which is 5. So I think we continuously get 0 0.5, 0 0.5, 0 0.5, 5, 5, 5, 5, like that. So because if you multiply, you get 45. If you subtract again, in normal cases, you divide, you say remainder 5. You stop there. In normal cases, for lower level, just say remainder 5. But in a nutshell, the point here, this is a recurring decimal. You're going to get 0.0.5555555. You're going to get 0.5555555. It will continuously repeat itself. So which we can simply abbreviate as 0.5, we put a dot on top. We write 0.5, we can simply write 0.5, and then we put a dot on top. 0.5, and then we put a dot on top. You can simply write, instead of writing 0.555. So we can define this as what? As a recurring decimal. We can define this as what? Recurring decimal. Because they are asking you, every one you do, you should tell whether it's a terminated decimal or a recurring decimal. Anyone that keep repeating itself is a recurring decimal. Any decimal that keep repeating itself is a recurring decimal. But the decimal that terminates, that ends easily, they are called terminated decimal. Is that okay? Now let's take a look at any other example if need be. Okay? The rest, for you to try yourself. You try and see what you get. Okay? You try and see what you get. This is same as 1 over 3. This one is same because 3 here, 1, 3 here, 3 to 9, 3. So it's 1 over 3. So which is 0.33333. This one will give you 0.3333. And so on and so forth. Okay? This same as 2 over 3. 6 over 9 same as 2 over 3. Okay? Because you reduce 3 here, 2, 3 here, 3, 2 over 3, 2 over 3, which is 0.6666. Okay, this is same as 0.666. So this one is same as the 0.6666, this 2 over 3, the 2 over 3 we talked about before, and this one is same as 1 over 3, which is 0.3. Is that okay? Okay. So that's what we have for this one. Now let's move to another problem. Let's move to another problem. What they want us to do here, let's see. Work out the answers to this calculation. Okay, this one, they've given us something, they want us to work out the answer. This is like the bid mass. Let's take a look at the bid mass, the operations of fraction. Okay, here I'm now going to explain fraction in a very, we digress a little bit before we apply the fraction. Now let's talk about the fraction itself. What do you need to do? In fraction, there are operations of fractions. Operations we do in fraction. One of the operations is addition. We add fractions together. Remember, before we talk about the operations of fraction, I say a fraction is a part of a whole. A part of a whole. So when you're dividing a fraction is, for example, if I give you this box, okay, I divide it to maybe 1, 2, 3, 4, okay, or maybe 5. 5. Okay, you can see this 1, this 2, this 3, this 4, and this 5. Okay. Oh my, I'm sketching. Okay. Now, this is a whole loaf of bread. We divided it to 5. For example, let's assume this is a loaf of bread. And we can decide to shade some good numbers of it. Okay. Okay, let's say we shade this. Okay, so this fraction, we can ask you, the shaded portion is 3 out of 5. It becomes 3 over 5. So that's why we write numerator and denominator. In a fraction, we have numerators, we have denominator. The top part of a fraction is called numerator, and the bottom part is called the denominator. What this one means, 3 over 5, it means out of 5 things, I divided by one long thing into parts. That's why we say fraction is a part. We define fraction as part of a whole. Part of a whole. The whole thing, you've divided it into 5, and then you decide to shade only 3. So 3 out of 5. That's what this one means. This is for the shaded. What if I ask you to tell me the fraction of the unshaded? This is for the shaded portion. This is for the shaded portion. If I ask you to tell me about the unshaded portion, then we will be talking about 2 out of 5. So for the unshaded, we write 2 over 5. Okay? So this is for fraction, basic fraction. 2 out of 5. For the unshaded, 2 out of 5. Okay? We can also have a circular example. Let's say if I have a circle, okay, and I divide my circle into probably 4. I divide our circle into 4, and then I shade only one of it. Let's say we decide to shade only this portion, and we're asking you for the shaded portion. So we say the shaded one is 1 over 4. The shaded one is 1 over 4. The unshaded one, this is S. S means shaded. The shaded one is 1 over 4. And the U one, the unshaded, is 3 over 4. 3 over 4. The unshaded is 3 over 4. So this is what fraction represents. Now we have types of fraction. Let's go to types. So with a connotated fraction, we have types of fraction. Types. We have, so I just write types. So for other types of fraction, we have proper fraction. We have proper. So I just write the word proper. We have proper fraction. The proper fraction is a type of fraction where the numerator, the top part, which is called the numerator, is smaller than the denominator. Okay, the numerator, let's say if I have 2 over 5, the numerator is smaller than the denominator. This is called proper. Okay, this is proper. Just like the rest of the body of human being is bigger than the head. So that's proper, right? It's a proper thing. If your head is bigger than the rest of your body, it's improper. So that's what we kind of relate this to. So this is a proper fraction because the top is smaller. This is called the numerator. This is called the numerator. Numerator. The top part of a fraction is called the numerator. And when it's smaller than the denominator, then the fraction is called a proper fraction. And this is a denominator. The bottom part is called the denominator. So when the bottom is bigger than the top, denominator. Okay, when the bottom part is bigger, it's a proper fraction. When the bottom part is smaller, then it's an improper fraction. So that's the first type of fraction. The second one is improper fraction. The second type of fraction is improper. Something that is improper, that is not supposed to be. Okay, like I said, the head is bigger than the whole body. That's very improper. Okay, improper. The head is bigger than the body, meaning the numerator, the top part of the fraction, is bigger than the bottom one. So like 5/2. This is improper fraction. Okay, this is improper fraction. The third case is the mixed number or the mixed fraction. What we call the mixed number or mixed fraction. The third one is mixed one. So we must learn how to convert from improper to mixed and mixed to improper. We must learn how to change fraction, mixed fraction or mixed numbers. Okay, so this is the third part. A good example of a mixed fraction is if I write one whole number or two whole number 3/5. Two whole number 3/5. You see, I have a whole number, a whole, then I have a fractional part. When I mix them together, this is called improper fraction. To change this one quickly, let's just talk about the change, the conversion. Okay, we cannot begin to do another video for that. Let's quickly have the chemistry of that. To change, you have to take the denominator, this denominator, you have to multiply it with this whole number. Okay, and then you add this numerator. And then you add this numerator. You don't say this one plus this one before you multiply. You take the denominator to multiply this whole number. Take the denominator to multiply the whole number. So in this case, it will be, if we want to explain, if we want to do this, it will be 5 times 2. 5 times 2. Remember, we said the denominator multiplied by the whole number. 5 times 2, you open a small bracket, you close in a bracket, plus the numerator, plus whatever is in the numerator, plus 3, all over the denominator. Remember that, always all over the denominator. So this will be equivalent to what? This will be equivalent to 5 times 2 is 10, 10 plus 3 is 13, so 30/5. So you've changed this mixed fraction or mixed number, you've changed it successfully to improper fraction. You change it successfully to improper fraction. Okay, now the same 30/3, if we want to change 30/5, this same 30/5, which is improper, if we want to change it to mixed number or mixed fraction, what do we do? We will find how many times 5 can go into 30 without a remainder. How many times 5 can go into 30 without a remainder? It can go twice, because 5 times 2 is 10. 30 is way less than 50. 50 is 3 times. Since it's 30, it's only 2 times. It can go into it without a remainder 2 times, so you write 2 whole numbers. What remains if it goes? 5 times 2 is 10, so 30 minus 10, you get 3. 30 minus 10, 30 minus you get 3. So then you write the denominator. You write the denominator 5. You write the denominator. So meaning you've changed it back to mixed number. You change it back to mixed number. Easy. If I give you 27 over, like I give you another number, 27 over 5, for example. 27/5. How many times can 5 go into 27? 5 times. Because 5 times 5 is 25. So it goes 5 times. So you write, since it can go into 27, 5 can divide 27 5 times without a remainder, you write 5 whole number. You write 5 whole number. What remains? Since it's 25, 5 times 5 is 25. 27 minus 25 is 2. So you have 2 whole number. And 2 over the denominator, 2/5. Right, 2 over the denominator, 2/5. So this is how to convert improper fraction to mixed number. This is how to convert improper fraction to mixed number. Okay, so this is converting improper fraction to mixed number. Okay, converting improper fraction. One last one. If we're given, let's say, 67 over 8. How many times can 8 go into 8 times 8 is 64, right? So how many times can go without a remainder is 8 times. 8 can go into 64 8 times. So 8 times 8 is 64. So 67 minus 64, you get 3. 3 over 8. Finish. It's easy to convert improper fraction to mixed fraction or mixed number. Vice versa, if you want to convert this one back, if you want to convert this, let's say we want to convert this one back to this. Remember I say multiply 8 by 8, this 8, the denominator, multiply it by this 8 whole number, and then you add this 3 over the denominator 8. So this will be 8 multiplied by 8, 8 multiplied by 8. You close it in brackets so that you don't get confused. Plus 3, plus this 3, you have to add the 3 after you multiply. Plus this 3 over the denominator, which is 8, over the denominator, which is 8. Over the denominator, which is 8. So this becomes 64. 64. 8 times 8 is 64. Plus 3, you get 67. So you get 67. You get 67 over 8. See, you got it back. You got it back, your improper fraction. So this is very well documented. One of the things you're going to be doing, okay, you're going to be doing in conversion. Now, we're going to go, since we know how to equivalent fraction, let's take a look at equivalent fraction before we move into operations of fraction. Equivalent fraction, here we'll be talking about, let's say you'll give you some fraction. Let's say equivalent fraction. A fraction that when they're reduced to the simplest form, they will be same as the smallest unit. For example, if I have 2 over 3, and you have 4 over 6, you have 8 over 12, they are equivalent fraction. Why? If you reduce this one to the lowest term, you will get the original unit, you get the original one. If you reduce this one to the lowest term, you get this original basic unit, or a basic fraction. So let's try this. Reduce this one, same number goes to them. 8 divided by 4, 8 divided by 4, you get 2. 12 divided by 4, you get 3. See, you will get this fraction 2 over 3. So fractions are said to be equivalent if you reduce the bigger fraction to the simplest form, you get the original simplest form. Okay, such fractions whose simplest form are equivalent, are same, are said to be, they are called equivalent fraction. They are called equivalent fraction. Is that okay? Now let's go to operations of fraction. Operation. Fraction can be added, can be subtracted, can be multiplied, and can be divided. Okay, fraction, we can do this basic BOD or big mass to fraction. We can do BOD or big mass to fraction. This fraction can undergo this whole big mass thing. Okay, we can do BOD or big mass, depending on where you're looking at it from. Okay, BOD to fraction. You do there could be bracket of in fractions, division, multiplication, addition, and subtraction. This is what we call BOD. Okay, so we can apply BOD to fraction. So let's take a look at a simple example. Fractions can be added together. Addition. So let's start with the addition of fraction. Addition of fraction. Fractions with same denomination are very easy to add. If I say 1 over 5 plus 3 over 5. See, once the denominator is same, then we just add the numerator. That's it. This one will become, this type of fractions are very easy to simplify. So we write the denominator the way it is, and then we add the numerator, 1 plus 3. We just add the numerator, 1 plus 3. Okay, we get 4 over 5. We get 4 over 5. We get 4 over 5. So once the denominator is same, addition of fraction is said to be interesting. But what if we have a case where the denomination is not same? Where the denominators are not same. For example, if I have 1 over 2 plus 1 over 3. 1 over 2 plus 1 over 3. Plus 1 over 3. Okay? We just stick to these two examples. We still use them for subtraction. We stick to these two examples we use there for subtraction as well. Okay. Now, if you have this, you see the denominators are not same. So what we can do, one way to do it, is you multiply each fraction with the denominator of the other one. If I want to multiply this one, I will take this denominator 3 to multiply the whole of this. So to multiply the whole of this, meaning I'll multiply the whole of this one with 3, both top and bottom, both the top and bottom. Then I'll multiply the whole of this fraction with the denominator of this one, which is 2. Okay, this is what you do. If you do this, you will not have same denominator. 3 times 1, you have 3 on top. 3 times 2, you have 6. So this is what we have here now. Plus this one. 2 times 1, you have 2 on top. 2 times 3, 2 times 3, 2 times 3, you have 6. So now you see we've changed it to have the same denominator. So once they don't have the same denominator, it's easy. You don't have to panic. What you need to do, take the denominator number of this one to multiply the whole of this. You see why I put 3 here? I took it from here. I took the 3 from here. I put it here to multiply both the top and the bottom of this one. So we get 3 times 1, we get 3. 3 times 2, we get 6. Then, same you do to this. Take the denominator of this one, which is 2, to multiply the whole of this. I put the 2 here. I multiply the numerator, I get 2. I multiply the denominator, I get 6. So at the end of the day, I get this. Now, since they are same, we say, once the denominator of fractions are same, just write down the denominator, and then add the numerator, 3 plus 2. Add them together, 3 plus 2, and then you get the next thing, okay? Next big thing. Okay, in IGCSE, you have all these simple questions in paper 2. As simple as it is, you have to be able to deal with it. So you get 5/6 if the denominator is different. Now let's do subtraction using the example 1 and 2 that we use for addition. Let's use it for subtraction of fractions. Okay, let's use the example 1 and 2 and let's use it for subtraction. Assuming we want to do subtraction of fraction, what do we need to look at? What do we need to look at? Now we come here, we say, the first example was, okay, this time I want to write this first because it's bigger. 3/5 minus 1/5. So I write problem 1, I write 3/5. Let's change, for subtraction, let's change our color dynamics. So we say 3/5 minus, subtraction of fraction, minus 1/5. In this case, you can see the denominators are same. Like I said, once the denominators of fractions are same, then the rest is a bit easier. The rest is easier. So you just write the denominator. You write the denominator. You subtract the numerator. Subtract 3 minus 1. 3 minus 1. It will give you 2. So our fraction, the answer to our fraction will be 2/5. 3 minus 1 is 2. Then you just write the denominator, 2/5. So this becomes easy, cheap and easy. Now let's take a look at the question 2. 1/2 minus, we use subtraction. Question 2, for subtraction, we say 1/2. 1/2 is bigger than 1/3. You know, I hope you know that. If you want to know, you change to decimal. If you change this to decimal, it will be 0.5. Change this one to decimal, it will be 0.333. So 0.5 is bigger than 0.333. So that's how you know, okay? Because sometimes they give you, in IGCSE, they give you a range of numbers, both decimal and fraction. They mix them, they ask you to arrange them in ascending or descending order. So you should be able to convert numbers so that you know which one is bigger, which one is smaller. Okay, so now this is 1/3. So if we want to subtract, like I said, there are two ways you can do it. It's either you find the LCM of the denominator, okay, or first of all, we change them to have the same denominator. So to change it to have the same denominator, we do likewise what we did just now. We multiply here by the denominator of the other one, the denominator of this one, which is 3, and we multiply here by the denominator of this one, which is 2. Okay, you can either use this method or use the LCM method. Probably after this, we'll look at the LCM method. 3 times 1, we get 3 over 3 times 2, we get 6 minus 2 times 1, we get 2. 2 times 3, we get 6. So you see, this is clearer enough now. Once you have this, you write the denominator the same, you just write 1 denominator. 3 minus 2, you get 1. So our answer will be 1 all over 6. 1 all over 6. Is that okay? So another method we can use is the LCM method. The LCM, if you don't want to change the fraction to be same. So 1 all over 2 minus 1 all over 3, you find the LCM of the denominator. The LCM of 2 and 3 is 6. The LCM of 2 and 3 is 6. So you just write 6 here. Okay. You say 6 divided by this, divide by 2. 6 divided by 2, we get 3. 6 divided by, you take the denominator, the LCM of the denominator, the LCM, you divide it by this denominator. 6 divided by 2 is 3. 3 times 1 is 3. We write 3 here. 6 divided by 3, the second time, you use this one now. 6 divided by 3, 2. 2 times 1, whatever you get when you divide, you multiply by the numerator. 2 times 1, you get 2. So you say minus 2. So 3 minus 2, you get 1 all over 6. 3 minus 2, you get 1. So whichever method you use, whether you use the LCM method or you use the changing the denominator to be same method, you will still get the same answer, 1 all over 6, as this answer 1 all over 6. The answer will be the same, irrespective of what method you use. Okay, so that's for addition and subtraction of fraction. What about multiplication of fraction? Fractions can be multiplied, okay, multiplication and division. Now let's take a look at multiplication. We put them together, multiplication and divisions of fraction. Okay, we need to know multiplication, division of bracket, and all of this of fraction. Multiplication / divisions of fraction. Division is very interesting because we have to change the sign to multiplication and flip the fraction that is on the right side. Okay, change the sign and flip the fraction that is on the right side. So let's say, for example, if I have 2 over 7 times 14 over 8. Okay, there are 2 ways to do this. If I have this now, number 1, for multiplication. There are faster ways to do this if you don't want big numbers and you don't want to use a calculator. Okay, you can simply say multiply the numerator by the numerator, as in take this one, just say 2 multiplied by 14, you get 28. So you write 28 on the numerator here, you write 28 here, and then you can also say 7 multiplied by 8, you get 56, right? So you write 56 here, and then you begin to reduce to the simplest term. You see, these are big numbers, especially if it's bigger than this. It becomes very cumbersome too. So you have to still reduce this. You have to still reduce this. It's like 28 and 28 is 56. So you see, you can say, if you don't know that this is half of this, you can break it down step by step by saying this one divided by 2, you get 14. This one divided by 2, you get 28, right? Something like that. This one divided by 2, you get 7. This one divided by 2, you get 14. And then 7 divided by 7, you get 1. This one is a long way, like you don't know. But if you already know, 14 divided by 7, you get 2. So you get 1 over 2 as this fraction. Okay? But if you already know, you can just say 28 to 28, you get 1. 56 divided by 28, you get 2. So if you know already, you can just go straight to the answer, 1 over 2. However, a shorter way for multiplication is that in multiplication, we can cancel. You see the 14 on top can be cancelled by this 7. So we can just go straight by saying 7 divided by 7, we get 1 here. 14 divided by 7, we get 2 here. Now these 2, or this one, any of the 2 on top, 2 divided by 2, you get 1. This 8 divided by 2, you get 4. Now you have 2 over 4 left. These 2 can be divided by 2, you get 1. These 2 can be divided by 2, you get 2. So our final answer is 1 over 2. So you can just start cancelling out in multiplication before you actually eventually multiply the numbers. before you eventually multiply the numbers, your final step, before you eventually multiply your final step. So this is one thing we do with multiplication, okay? So now let's take a look at division. If we have number 2, we just take one example for multiplication, one example for division. If we have, let's say, 2/7 divided by 7/8. Okay, divide by 8/7. If you give you something like this as division, okay, in order for us to do division, what we need to know or what we need to do is to first of all write the first fraction, the fraction on the left, this one, 2/7, write it down. And then we change the division sign. We have to change it to multiplication. We have to change it. And in changing it, you have to flip. It comes with a rule. You have to flip this one. The top will come down, the bottom will go up. You flip, this becomes 7/8. This has to become 7/8. You must, in changing this is the only thing you need to know in division. Because it becomes like multiplication. Once you change the division sign to multiplication, you have to flip the fraction on the right. You have to flip the fraction on the right. The numerator will go up. The numerator will go up. And the denominator will come down. You have to do this. See, 7 goes up, like in this case, and 8 goes down, like in this case. After that, the rest is like multiplication. The rest is same as multiplication. The rest of the job is same as multiplication. So 7 cancels 7. In multiplication, you can cancel out. Okay, you can 7 cancel 7. 7 divided by 7, 1. 7 divided by 7 here, 1. So it's out. 2 here, 2 divided by 2, you get 1. 8 divided by 2, you get 4. Now you multiply the numerator, you multiply the denominator. What is left here? 1. 1 times this one is 1. 1 multiplied by 1 is 1. Don't say 1 multiplied by 1, 2, okay? If you do that, you're doing good. Okay, you need a proper school. Then, in the denominator side, you say 1 multiplied by 4. 1 multiplied by 4, you get 4. So, this is the answer we get if we do this division. So, division, all you need to remember, we're going to change the sign to multiplication, and we're going to flip the fraction on the right. Not the first fraction, not this one, the right one. We're going to flip it. That's it. Then the rest become a normal multiplication operation. Then there's what we call the bid mass, the mix operation in fraction. Now let's take a look at example of a mix operation in fraction. Let's take a look at example of a mix operation. See, here we have 2.5 square minus 2.5. Okay, this is a mixed operation. 2.5 square minus 2.5. Question number 3. We have 2.5. See, that's why I say bid mass. Square now is the power, either bod mass or bid mass. Okay, bid mass, the I in bid mass is power or indices, bid mass. What we call the bid mass. Either you say bod mass or bid mass. In this case, this I is the indices or power. Okay, minus 2.5. So if you have mixed operation like this in fraction, we can do and undo. So first and foremost, we can change this to improper fraction first. So to change this to improper fraction, we say 2 multiplied by 2, right? 2 multiplied by 2. I don't want to, like, I've already explained that. 2 multiplied by 2, we get 4, plus 1, we get 5. So we have 5/2, okay, square. 5/2 square. We have 5/2 square minus 5/2, because it's the same thing. minus 5 over 2, minus 5 over 2. So if you have mixed operation like this, then what you need to do, if you square 5, it doesn't mean 5 times 2, 10. Don't go and write 10. It's squared. Meaning 5 is something like this. See, 5 squared over 2 squared. This is what it means. This is what it means. Don't go and write 5 times 2, 10. Okay, minus 5 over 2. This is what this one means. So the next step is to, if you square this, you get 25. So 25 over 4. That's what you get. If you square 2, you get 4. 25 over 4 minus 5 over 2. Now we are in there. We come back to subtraction. So like I said, we can make them same. Now if you have this type of numbers, please pay attention here. If you have this type of number, you know, just now I said if you want to make the denominator same, use this one to multiply this, and you use this denominator to multiply the whole of this, and use this denominator to multiply the whole of this. Yes, even if you do that, you get the same thing. But when you see that one is a square of the other one, you can just multiply here with 2. To make it same as this only. Because this number, once you multiply with this, you get this. So you can only treat here without treating here if you have this type of fraction. Which means we will get something like this. So we still have our 25 over 4. We still have our 25 over 4. Minus, if you multiply 5 times 2, you get 10. Over 2 times 2, you get what? You get 4. So you see the denominators are same now. So once the denominator, I only treated here. But you can do both. But if you do both, this number gets bigger. To avoid the big numbers in fraction. So we can treat this because if I multiply the denominator here by 2, it's already equivalent to this. The denominator is already equivalent to this. So when you have such situation, you can just take any number that can make this one to be equivalent to this. If the number is 3, you multiply it by 3. If it's 2, so here we needed 2 to multiply this denominator to make it 4. So we just chose 2. Is that okay? It's not like we're picking from any of the denominator. We just chose a number that will make the denominator of this to be same as this. We use that number to multiply this. So that's how that's how we got this one. And the moment you get this, the next thing to do is just to do the needful, which is the denominator is a common denominator in this regard now, 4. And then you say 25 minus 10. 25 minus 10 will give you 15. So your answer is 50 over 4. But you can leave your answer in mixed number or mixed fraction. How many times 4 can go into 15? 3 times. Because 4 times 3 is 12. Then remember what? 3. Remember 3. 3, because if you say 15 minus 12, you get 3. 3 over 4. So this, either you leave your answer like this, but most likely you leave your answer in there, mixed fraction. Mixed number or mixed fraction. So these are final answer. These are final answer. So this is what is required. Once you know how to do, they will play with you, they will mix it, they will give you different operation, but the rest assured is just what you know. Just go flow with it step by step, and you get to the end of it. You get to the end of it. Is that okay? You get to the end of it. Okay. Okay, so look at this one. Here we have multiplication first, we have a bracket, so let's take one more example of this type, and then we can move ahead. We have 9 times 3 over 1 over 3 minus 2 over 3 squared. Okay, so let's just take this and then we can move ahead. We no longer number our question 3. Okay, for this type, question 3. For mixed operation or operations of fraction. So we say 9 multiplied by 3 whole number 1 over 3, right? 1 over 3 minus what? Is it 2 over 3? Minus 2 over 3 squared. So minus 2 over 3 squared. 2 over 3 squared. This is a bit mass. This is a bit mass. There is multiplication, there is power, indices, there is subtraction, and so on and so forth. So they can mix fraction for you like this. It's not a big deal. Let's simplify this one first. If you simplify this, what will you get? What will you get if you simplify this? 2 squared means 2 times 2, that's 4. So here we have 4 over 9. Because this is 3 squared, not 3 times 2. 3 squared. 3 to the power of 2, you get 9. So here, this is what we have. This one, let's change it to a proper fraction. 3 times 3, 9. 9 plus 1, 10. So we get here 10 over 3. We get 10 over 3 here. And then we have multiplied by a whole number. Multiply by a whole number. So you see, in bit mass or board mass, multiplication comes first before subtraction. In bit mass, multiplication comes first before subtraction. You get it? So you do the one that comes first. See, multiplication comes first. Look at multiplication here. It comes first before addition and before subtraction. If there was division, we would have done the division first. You see the one I did first? Because it's I, the power. I simplify with the one that has power first. After I have done the power, now I'm doing the multiplication, which means I have to do this together first. Because it's multiplication, multiplication comes first before we now subtract. Okay, now in doing this, this means over 1. Whole number means over 1, right? So without much stress, what we can simply do here, we can just cancel out. 3 divided by 3, we get 1. 9 divided by 3, we get what? 3. 9 divided by 3, we get 3. So we multiply. What do we get? We get 30 over 1. So we get 30, which is whole number actually. Okay, whole number over 1. Minus 4 over 9. Minus 4 over 9. Minus 4 over 9. So this here now we have a subtraction or fraction. Subtraction. So it's up to us. We can find the LCM. We can find the LCM, or we take the denominator of this, multiply here, and we take the denominator of this one to multiply here. So it's up to us which method we want to use. So if we find the LCM of 1 and 9, it's 9. 9 divided by 1 is 9. This 9, the denominator, divided by 1 is 9. Is 9. 9 times 30, because 9 times 3 is 27, so you write 270. 270 minus 9 divided by 9, 1. 1 times 4 is 4. So 270 minus 4. So we get, for this fraction, we get 270 minus 4, that's 266, right? So we get 266 over 9. This is an improper fraction. Can 3 go? To know if a 3 can go into a number, you have to, the sum of the number must be divisible by 3. So this plus this is 12. 12 plus 2 is 14. 3 cannot divide 40, so 3 cannot divide this number. So is either we leave like this, or we change to mixed fraction. Or we change to mixed fraction. So that's what it is for this question. Is that okay? So that's that for this question. So every question has its own unique approach, but you need to know the basic things that binds a fraction that helps us to solve a fractional problem. Okay, that helps us to solve fractional problem. Okay, same thing. There's bracket. You do the bracket first. Once there's bracket, you do this bracket. So I think we just do one more. We round up with that for this. One more problem, we round up with that. Every other problem, you make an attempt. So if you have this 5 whole number, 2 over 3 plus 3 over 5 minus 1 over 2. Let's write this and let's try and solve this. Okay, 5 whole number 2 over 3 plus 5 whole number Question number 5. 5 whole number, 2/3. 5 whole number, 2/3, plus, right, plus bracket plus bracket 3/5 minus 1/2. 3/5 minus 1/2. 3/5 minus 1/2. Okay, we'll give you this question. So it's same, we're going to like follow bit mass. We're going to follow bit mass or board mass. Bit mass. Every time you have a fraction, mixed fraction like this, and they want you to do the operation, you follow bit mass. Now in bit mass, there's bracket. So we have to solve anything on the inside the bracket first, because there's bracket. So in solving that, we already have a fraction that do not have the same denominator. So which is 3/5. We have 3/5 minus 1/2. Minus 1/2. So we can make the denominator same by simply saying multiply this one by 2, the denominator of the other one, and then multiply this one by 5. Multiply this one by 5 to make the denominator same. So 2 times 3, I get 6 in the numerator. 2 multiplied by 5, I get 10 in the denominator here. So minus 5 multiplied by 1, I get 5 here. Over 5 multiplied by 2, I get 10 also here in these denominators. You can see the denominators are same now. Once they are same, we just write it one time only, and then we subtract the numerator. 6 minus 5, you get 1. 6 minus 5, you get 1. So this inside the bracket, we get 1/10. Inside the bracket, we get 1/10. So that 1/10 will be faced off with this one. You say this plus 1/10. So what I have here now will be, I write the plus here. I write my mixed fraction. 5 whole number, 2/3. So I change this fraction to improper fraction. So I can continue. I change this one to improper fraction. So I can continue. So in doing that, we already explained how to do that. We don't have to waste our energy or time. So we just go by saying 3 times 5, 50. 50 plus 2. 3 times 5, 15. 50 plus 2. 50 plus 2, 17, right? So we get 17 over the denominator, which is 3, plus 1/10. Plus 1/10. So the next thing to do is either we take the denominator of this to multiply this, and take the denominator of this to multiply, or we find the LCM of the denominator. Since the last one we used the LCM of the denominator, now let's use the multiply both sides with the denominator of the other one. So we can singularly take this, multiply by this denominator, which is 10, and this one multiply by the denominator of the first one, which is 3. So when we do that, we get 10 times 17, you get 170. You get 170. Remember, you don't cancel, even if number in plus and minus, you don't cancel the top and bottom of fraction. Only in multiplication we cancel out. In addition and subtraction, we don't cancel. Even if the numbers can cancel, you don't cancel out. Okay? So 3 times 10, you get 30 in the denominator here. Then we say plus 3 times 1, you have 3 here in the numerator, over 3 times 10, you get 30 in the denominator here. Now you can see the denominators are same now. Once the denominators are same, you write it once. Okay, you can now simplify the fraction. And then you add. Since this is plus, you add this 170 plus 3, you get 173. 170 plus 170 plus 3, you get 173. You add the numerator. So that gives us 173 over 30. 173 over 30. So the next, if you like, you leave like this, or you see if you can simplify. If 3 can go into this number, you add them. A number is divisible by 3 if the sum of the number is divisible by 3. 1 plus 7, that's 8, plus 3, that's 11. So 11 cannot be divided by 3. So this whole number cannot be divided by 3. Okay, so is either you leave like this or you reduce to mixed fraction. How many times can 30 go into 170? It can go to 150 5 times. So 186 times. So it's only 5 times. It will now remain 23. 23 over 30. 5 whole number, 23 over 30. So it's either you live like this or you live in like this. Whichever way is okay. So I think for fraction, this is what we will do for today. The remaining ones, if there are questions, to be able to, we give you the basic knowledge to be able to solve any problem. The rest are exercise, should be able to solve any problem arising from fraction. Okay? So with this, we've come to the end of our class. Thank you for joining us.